Welcome everyone. Now let's try to use the SQL Server. First of all, let's start it with this icon. And we connect to the SQL Server. You can choose from two types of authentication, the Windows authentication or the SQL Server authentication. In case of SQL Server authentication, the usernames and passwords are stored in a table in the SQL Server. This is the less secure solution. And the other form is the Windows authentication. In this case, your Windows username and password will be used for the authentication. There are some cases when we prefer the SQL Server authentication. For example, if there is a web server in the demilitarized zone and it wants to connect to the SQL Server, then of course we don't want to join the web server to the domain. In this case, the SQL Server authentication can be used. If the SQL Server and the computer want to use the SQL service in the same domain, then most probably the Windows authentication is simpler and more secure solution. Now for the simplicity, I choose the Windows authentication. I am the administrator, so I can connect. And here is my SQL Server. Our first task is to create a database. So here are the databases. And if I just right click here and create a new database, let's try to create something. For example, I will call it as X. You can set an owner to the database. Now it isn't important for us. You are able to set the file name and where do you want to store the file. For example, here. And you have to use at least two files. One of them is the primary database file. It is with the extension MDB. So in case of Microsoft SQL Server, you have the MDB file. That's the primary database file, and it is mandatory. You always have to have at least one. The other one is the RDF, that's the transaction log file. It's also mandatory. And you can create, if you want, secondary database files. Those are the NDF files. Those are the secondary database files, and these are not mandatory. So here are the different file types. Now we will create a simple database. We will use only the MDF and RDF, and we will not create any secondary database file. Okay. In case of the options, for example, you can set the recovery model if it is full or not. Collation, that's practically the ABC ordering, and the compatibility level. Now, this is a SQL Server 2012, and I want to compatible only with this one. Okay. I click on the OK button, and the new database is created. If you click on the database, there are different parts. For example, here are the tables. You are able to create tables here. Let's try to create some. First, let's create a simple example. In this example, let's create an employee record because it's easy to imagine for everyone. So, go to the tables, right click, new table. And first of all, let's try to figure out what kind of columns we need. Employee record. Of course, we will need an employee name. Employee name. We will need some department where the people works. Some birthday, birth date, and for example an address. And now that's all. One more thing, in every table it is recommended to create a unique ID column because, as you can easily imagine, there can be many people with the same name, so the name is not a unique ID. Of course, you can use some security ID or whatever to identify the people, so some so-called natural ID. But as you can imagine, in different countries that kind of ID is different. So if you want to prepare for some multinational application, what can be used in many countries or whatever, it's always recommended to use some unique ID what is generated by your application. So there will be an ID as well. Now we have to figure out the types of the different fields. For the ID, I will use the simple integer type. That's fair enough. You can store many millions of peoples, so it will be enough. For the employee name, that's some kind of string. So let's see what kind of string values we have in case of SQL servers. We have the following naming convention. We have the char type. This is the string type of the SQL server. And before the char, we are able to add some additional stuff. For example, it can be varchar, or it can be varchar, or it can be n-char. So what is the meaning of the var and what is the meaning of the n? That's the question. The n means the national, so practically the Unicode characters. You have to use it if you want to use some kind of special national characters, for example, if there are acutes or some Chinese character or whatever. Today, because most of the applications are created for the international market, I always recommend to use the N type character styles. In this case, one character is stored on 2 bytes. While in case of simple char types, one character is stored, of course, in 1 byte, so those are the ASCII characters, and this is the Unicode one. The var means the variable length. What does it mean? I always wrote here some kind of brackets, because for every type you have to give a maximum size. For example, to the char type, char 50 means it is a character field and maximum 50 characters you are able to enter. If you are using the char type, so the simple one, then the SQL server will fill the space to be exactly 50 character long. So if, for example, if you write only 5 characters, then it will put there 45 filling characters. By default, the filling character is the space, but it can be changed. In case of variable length, the SQL server will store the length plus the value itself. It means it doesn't need any filling characters to store the data. So in general speaking, the var character requires less storage space, but of course, because you have to read the length, and after that you will be able to read the value, it will be a slightly slower working mechanism. As you can imagine, the length is stored on 2 bytes. Oops. 2 bytes. And after that coming the value of it. So it means it works to use varchar type variables only if the length of the field is greater than 4. So practically it doesn't work to use, for example, varchar 3. It's simply, it has no sense. Why? Because if you think about it, you say that you want to use maximum 3 characters. It means the value can be between 1 and 3 characters. So let's say in average it will be 2 characters long, plus the length is stored on 2 characters as well, so altogether 4 characters will be stored. While also it means in case of varchar 3 you need 3 characters, in case of char 3 you need only 3 characters, so you were even wasting 1 byte. So it simply doesn't work to use 2 small var character fields. So the employee name, because we are creating it for the international market, let it be some n, because the name is can be quite long, let it be varchar, and the maximum size, let it be, for example, 50 characters. Hopefully the name can be fit on 50 characters. Of course, it's better to use longer space if you are not sure than a shorter one, because sometimes it is more difficult to increase the size. The whole database will be rebuilt. In that case, the pages must be reorganized and whatever, so it can be a bit time consuming. So it's better to create a bigger than smaller one. The next one is the department name. For the department name, we will use again some varchar type, and let it be, for example, maximum 50 character. For the name I will use 50 character as well, now I don't have to take care of it. For the birth date. The birth date is of course a date field. Since Microsoft SQL Server 2008, you are able to use the type date, which is as I mentioned, it introduced in Microsoft SQL Server 2008. It stores only the date. The older version is the date time, which was storing the date and the time as well. And since 2008 there are other date types. Now for us the simple date type is fair enough. And for the address, we will use again some string values, for example mvarchar 100, because it can be a bit longer. So those are the data what we want to store from the employee, and we want to create a table based on those information. Let's create the table. First of all, some words about the table. The simplest thing to imagine the table is, for example, an Excel worksheet. But contrary to an Excel worksheet, you have to define the type of the different columns. For example, in case of Excel worksheet, you are able to write to the first row, first column, for example, the value 1, and under it you are able to write a string. So the same is not true in case of SQL servers. You have to define for every column what is the data type you want to write there, and that's why we had to sync it over. So the first column will be the ID, and I will define it as an integer value. So I will use the simple int. And there is one more column. This is the allow null column. Some words about this column. There is a special data in case of SQL servers, that's the null data. And the null data, it has some very interesting features. It practically means the data is not entered, so it's not filled. That field is not filled with anything. So this is the meaning of the null. And it has some interesting features. For example, null is not equal with null. And it can be very disturbing when you first meet with the SQL language, because if you want to filter the data, later we will do such an examples. For example, you write that where, for example, department equal null, you will get always empty result set for such a query, because the null is not equal with null. If you want to test if some value is equal with null, you have to use the is null statement, and this is very important for every SQL server. That's why I wanted to mention it at the first place even now, to not forget it. So the question is here, if you allow here null, so practically if you allow this field not to be filled or not. Now I don't want to allow here nulls, because everyone should have some unique identifier. After that, I want to write the other column is the employee name. So I just write here employee name. That will be the second column. And as I mentioned, it will be some mvarchar, for example, 50 type column. And you have to decide if you want it to be empty or not, so not filled. Again, it is a good question. Practically every employee must have a name, so you maybe clear the checkmark from here, but you can decide it on the way. You don't want to add such a constraint to your database, but you check those kind of constraints always by your application. It's practically a design question. If the SQL query enforces the constraints or the application enforces the constraints, I don't want to argue on that. Which one is the better solution? Also has advantages and disadvantages. Now we will write the department, because now we are dealing with SQL Server. I will enforce everything with SQL as well. Department name, and it will again some mvarchar, for example 50, and now just to test it, I let it to be null, because for example when you first enter the employee, you don't want to immediately fill the department. Birth date, so birth date, and let it be some date type variable. And finally, we have the address. Again, this is some mvarchar type, and let it be a bit longer, for example 100 maximum. Great. We have the table defined. Now we can save it. Let's click on the Save button, Save Table, and give it some name. For example, the table 1 is a quite fine name for me. So, okay. We created the table 1, but where is it? Because you are not able to see it. Most of the SQL servers, or most of the front ends to the SQL server doesn't like to refresh the screen. So if you don't see something, then don't try to search for it or whatever. First use the refresh button, maybe it helps you. So you can use this refresh button or press the F5 if that's better for you. So I am here on the tables, press the refresh button, and here is my nice table. So it is really there, just the screen was not refreshing. Okay, now we are creating some simple database and a simple table within that. Now let's add some data. Oh, if you open the table, you will be able to see the columns here as well. If you right click to it, you are able to design, so modify the columns or add new columns and save it again. Right click on it and edit top 200 rows. This is how we can write some data to this table. First of all, here is this ID column. I write here the value 1. Employee name, it will be the employee A. Department name, it will be the department A. Birth date, let it be 1970-0101. And the address is the address A. So I added some data. As you can see, there are red exclamation mark next to the data in every cell. Because I haven't saved the data yet, how to save it? You just simply click to another column. Other row, and it will be saved. So now I can save the second employee, it will be B. It works on the department B, and he was born or she was born in 1960-0101, and address B. And let's create a third employee, it will be the C. He will work on department C, 1980-0101, and address C. So I created some simple table with some sample data. Great. So this is how you can enter data to a table. Now I just close it. If you want to see the data, again you can use the edit top some data if you want to modify them or add new lines. Or you can use the select top 1000 rows if you want to see only watch the data. As you can see, the SQL Server immediately wrote you the select. Here it is. So in the background, of course, it runs that instruction to give you the result. Okay, now let's do it manually. So I click on the new query button and write the same query. Similar query, more exactly select. If you want to get them some data from the table, from some tables, then you have to use the select keyword. After that, you have to define which columns you want to query. So you have to add here the column names. For example, the first column is the ID, then the employee name, and so on. ID. You are able to pull here the name of the column, then you don't have to type it. You see some difference when I typed it. Then there were no square brackets around the name, but when I pulled it put some square brackets around the name. Why it happens? Because if the column name contains some special characters, for example spaces or some prohibited characters, then you have to use the square brackets to show the values belonging to each other. It is not mandatory, so if your column names doesn't contain special characters, for example space, then you don't have to do it. And after that I can add the other column names. If you want to select every column, then you can use the star. It means every column which is available. To tell honestly, for the first time I used the star and then write the table name, like for example from table table 1, and after that I come back here and write here the column names, because now if you start to write the column names, then it will just give you, when you start to type employee name, as you can see, it gives you the different possibilities. So I prefer to write it this way. So every time I start with the star. This kind of query, like select star from table 1, it will give you back every data from the table. In case of SQL, we do not really like this kind of queries because it gives you back the whole table as a result. As you can imagine, if the table is very, very large, then it will give you back a lot of data. It can run long time. It will waste the SQL Server resources and so on. So most of the time we like to filter the columns, not query everything, only query what we need, and not query every row, only what we need. But now for the beginning, for the first query, it's quite fine. Some word about the syntax. As you can see, I always type the SQL instruction with capital letters. It is not mandatory, but most of the time it's done on this way, because in this case it is simple for you to differentiate between the SQL instructions and the other data, for example, a table name or a column name. So I recommend to follow this habit or custom. And then we can click on the execute button. Be careful to click on the execute, not to the debug button. So the play is now the debug. The execute is the exclamation mark. And as you can see, we really got every result from the table. Okay, we were able to create a simple table containing some employee data. But as you can imagine, this is not the best method to store employee data. Why? Here, I wrote, for example, the different department A, B, C. But as you can imagine, when you store the different employees, then before or later, at least 2 employees, 3 employees, more employees will work on the same department. What does it mean? If you start to fill the data, you always have to write here the department name, and maybe somebody mistypes it during the recording of the data. Or somebody starts to abbreviate the department name, or the department is renamed and you have to change it in many places, and so on. So it is always recommended to find those kind of data, what repeating, for example, the department name. Many people can work on the same department, and store those data on a different table, and only give the user the possibility to choose from those values. So because in this case, one time you record the department name and then you don't have to record it again, it has a much less chance for the typos. And also it has another advantages, it will require less space. Because if you always write here the department name, for example, now I wrote here department A, it's 1, 2, 3, 4, 5 characters, because it is an M worker, so one character is stored on 2 bytes, it is altogether 10 bytes used on the disk. But if I store the department names on a different table, and I store the department name only one time, then of course once I have to store the department name, but when I use it second time, I can use only a smaller reference to it. So what does it mean? Let's recreate this employee record on the following way. We will have an employee table, and the employees still have some ID, and instead of the department name, it will have a department ID. It will be some integer, and it will be some integer. Later I will come back here. And what else do I want to create? I want to create a departments table, and here I will create a department ID field also, and here it will be an integer value, and here I will write the department name, what will be some M worker, for example 50. Okay. And what do I have to do? I have to record here the different departments names to this table, and then to my employees I'm able to write instead of the whole department name only a short number. For example, he works on the first department, on the second department, and so on. And based on this number, I will be able to search the department name. This is the so-called joining of tables, when the department ID must be the same, and I search from the other table required data based on this equality of those values. And of course, I will have here some birth date. It will be some date type field. And earlier I write here some address. But again, as you can imagine, to store the address on this way, it's not the best one. Why? Because, for example, you are not able to filter the employees based on, for example, the city where they are living, or the postcode or something, some other information. So most of the time we not used to store the address like this one in just one field, like mvarchar, whatever, like I did it earlier. Oops. But again, we want to separate this information. For example, we want to save the city separately, the postcode, the address, of course, and maybe some region and some other information. But if you do it on this way, you have again the following problem. Most probably you will have many employees from the same city and many employees from the same region. So again, to store the city name on this table, it is not really recommended stuff, because you have to store much more data in this way. Instead of a smaller number, some smaller reference, you always have to type the whole city name. It will be mistyped, it will be abbreviated or something like that. So it will be very difficult for you to find everyone, for example, from the same city. That's why we will use the same idea like earlier. We will create some address ID field, and it will be some integer value, and we will create some addresses table to store the addresses. And here we will add an address ID to be able to join the two tables. Of course, it will be again an integer value, because earlier I mentioned it will be an integer value. And I will write here the address itself. It will be some mvarchar, for example, 100. Of course, I have to store the city and the postcode and the region as well. But again, if you add the city to the address table, most probably many people will be from the same city, so you have to write the city many times. So instead of it, we will use the city ID here, int, and put the city to another table, what will be called as cities. And here we will add the city ID. It will be some integer type value. There will be the city name, that's the mvarchar. Let it be, for example, maximum 50 character. Hopefully that's enough for a city. It can be argued if you want to write the postcode here, because, for example, to one city there can be many postcodes, especially if it is a bigger city. Then maybe you can record the cities of different districts, different city names. It can have many, so you can have many solutions. Or you can add the postcode to the address, not to the city. That's also a nice solution. It just depends on how you decide it. Now for the simplicity, I leave here the postcode. I don't want to bother with it. And let it be some mvarchar, for example, 20 characters long. That's most probably enough for any postcode. And then you want to write here some region. Again, the same problem. Most probably there are many cities in one region, so it doesn't work to write here the region name itself, because there will be again repetitions in the data and so on. That's why we write here some region ID, and it will be some integer type data, and we create a new tables for the regions, and we will write here some region ID, and it will be some integer type, and some region name. let it be some mvarchar, for example 100. Great. So we divided our data to smaller parts and separated every repeating data to a different table. This process is the so-called normalization. Of course, now I didn't do the formal normalization because it has nice mathematical description and how to do it, and there are different so-called normal forms from 0 until 6. Most of the time in practice the third normal form is used, and that's enough for every practical purposes. Generally, for a beginner course, it's enough you to understand the logic behind why it is necessary and why we want to separate the data to different tables. And the logic behind is that we don't want to write repeatedly the same data. We want to write one data one time and then only to reference to that data. That's all. Let's try to solve the problem again on this way. So I go to the tables and let's try to do this structure. Create a new table. We will have the employee table. So let's try to create those tables. The employee table contains the ID, the department ID, birth date and address ID. So ID, it will be some integer value. The employee name, it will be some mvarchar, for example 50, and those shouldn't be null. And the next one is the department ID. It will be some integer value again, integer value, and the address ID, it will be some integer value again. Great. Now let's save this table. So again I just click on the save and I will call it as employees. This is my employees table. X. I save this, close this query window as well. Again, you don't see the table here. If you click on the refresh button, oh, it's there. Now let's create a second table, new table. It will be the addresses. So it will contain an address ID. It will have a data type int, and it shouldn't be null. And I will give it some address. It will be mvarchar, for example 100. The address can be long one, street name and whatever. And I want to add here a city ID. And as you remember, it should be an integer value. Save again. It will be addresses table. The next one is the cities. One more thing, again you don't see it. If you click on the refresh button, it's there. New table. Let's create the cities. There will be some city ID and it will be an integer value. And the city, it will be some mvarchar, for example 50. I don't want the ID to be null. Or the city name. Now I leave it. And I decided to write here the postcode and let it be some mvarchar, for example 20. Most probably enough. And I will write here, add here the region ID, what is also an int type variable. Great. Save it, and it is called as cities. Again, if you refresh, it will be there. And the next one will be the regions. Right click, new table, region ID, it will be some integer type. And because it is a unique ID, I don't allow there the null value. Oops, there is a typo. Region ID. And region name, it will be mworker, for example 50, that's fine. The region name. Again, I save it, it will be the regions table. Save. And finally, we will have a department table, departments, contain department ID and the department name. Let's create it. New table, department ID, integer, and department name. It's an mworker type field. And again, because this is a unique ID, I don't want it to be null. And save it, it will be the departments. Fine. Now we created another structure to store the same data. So as you can see, first we stored those whole information in one table. Now we store the same information, but now in 5 tables. So our database contains much more tables. But hopefully, because of this arrangement, there will not be so much redundant data, but will decrease the probability of typos and abbreviations and other stuffs, and also most probably it will require less space on our computer. So let's continue with querying some data from those tables.